Hello, I am Tabitha Prater, and I am a graduate student here at UCA, and we are going to talk about repeated measures ANOVA. So what is a repeated measures ANOVA? It is when we manipulate the independent variables using the same group rather of people or plants or animals or whatever our group is or our person is. We use the same one across different time periods. So it's easier to explain it as an example. Here we have the same group of people. We have, you can tell they're all the same. And we give the same group of people a happy pill. And then we give the same group of people, maybe a month later, we give them a different type of pill and see what the effects are. And then a month later, we give them this pretty red and blue pill to see what the effects are. So the reason that we would use the same group of people, there's actually several. It can be more sensitive due to you have more control over your variance. So your systematic variance is the part that we intentionally manipulate the pills in that example. And then the unsystematic variance, that's going to be your unknown factors, your noise in the background that is happening that you really can't control for as much. You have a little more control if you're using the same people over and over versus if you do a ANOVA where you are using different people. So one group would have one pill, one group would have another pill, and one group would have another. We can control for, say, one group might have had more females, and that could affect your outcome, or the second group may have, a couple of people that are just super sensitive to medication, and that can be a factor. So by using the same group of people over and over, you could better control for those types of factors. And it also is more economical. You're not going to have as many participants because you're using the same participants over and over. So essentially, it's going to be less time in gathering participants and potentially less cost if you're, say, giving your participants all a financial benefit to participating in your study. But there are a few problems, and the main one is fatigue. So people may know what to expect. So if you are doing several experiments with the same group of people and over again, they may start to be able to predict what is coming and adapt to that. Or they may just get tired of doing the experiment. That could result in people not completing the experiment. It can just result in them, just being tired of it, exhaustion, and not doing as well at their last, when the last variable is applied versus when the first one was. So we can help that by giving the participants breaks. You can put the manipulation in different orders, so each person kind of gets a different manipulation, a different variable at a different time, but they all get the same treatment, just at different times. So when we do the repeated measures ANOVA, we are going to do the same assumptions as a regular ANOVA. So the assumptions of independence, you will have a violation usually of assumption of independence just because you're using the same participants over and over. So we also measure something called sphericity. And that is a correlation across conditions. It assumes that the correlation across conditions is going to be the same. So the dependency between scores is going to be the same or similar between the conditions, and the variance of that essentially means the variance of difference of scores is all the same. So we test that using Mauchly's test. So if P is less than 0.05, then sphericity is violated, and if it is not significant, then sphericity is met. So we essentially want it to be met. So if it's violated, you use a correction. You can use Greenhouse Geyser, or you can use, I can't say that, Hunenfeld, or you can also take the mean of the two. So, let's see. Okay, so let's jump into how to do a repeated measures ANOVA in SPSS. So here I have my variables. I will go to Analyze, and then down to General Linear Model, and click on Repeated Measures. From there, I'm going to fill in my factor name and the number of levels. So what I am testing for in this example is BMI in the same group of people over a time period at baseline, year 1, year 2, year 3, and year 4. So I have, or excuse me, not year 4. Baseline, year 1, year 2, and year 3. So I have 4 levels. And so I put that, added those. And then I take those from over here, and I have put on the left, and this was turned the other way, and I put those measures right here. And then I go to contrast. And polynomial is what is automatically selected. I'm going to hit repeated measures. And then I want my descriptive, so I'm going to go to Options and hit Descriptive Statistics, and I also would like my parameter estimates. And then I continue. And here's the output. Make sure I didn't skip anything. Yeah, here's my output. So you can see in my descriptive statistics that I have 183 participants. They obviously all finished the test because there are 183 at baseline, 183 at year 1, at year 2, and at year 3. Next is my multivariate test. Okay, and here is my Mauchly's test of sphericity, and you can see that sphericity is significant, so therefore it has been violated. So because sphericity is violated, we will do the test. We will look at the Greenhouse Geyser and or the Hunenfeld test. So I'm going to just use the Greenhouse Geyser for this example, and F, I get these F, the degrees of freedom right here. I get that from the Greenhouse Geyser. I hope you can see my cursor when I'm doing this. The Greenhouse Geyser degree of freedom, and then I go down here to my error, and that is the second degree of freedom. And that equals, the F statistic is 118.026, and it is significant. And here I have my lower and upper bound confidence intervals. And then my pairwise comparison. So with my pairwise comparison at the end, this is where I can see where the difference lies. This one's actually pretty easy to see. Just like the ANOVA, we're looking at BMI at baseline compared to now these numbers can be a little tricky because baseline is 0, year 1 is 2, year 2 is 3, and year 3 is 4. So keep that in mind. But I can see that my difference lies mostly right here. Year 4 is significantly different from, year 3. See, I already got it wrong. Year 3, BMI is significantly different than it was for at baseline, year 1, and year 2. So that tells us that whatever our manipulation was did affect BMI, and there is a difference in BMI. All right, and so this is actually a really good example of why repeated measures using the same group of people is beneficial. Because if I were to be using different groups of people at baseline, and then a different group at year 1, and a different group at year 2, and a different group at year 3, there could have been so many other variables that I could not have controlled for. Those groups may have had so many, their genetics may be different than each other. There's lots of problems that I could not control for. So by using the same group of people, I'm able to, I know that they're all the same group of people, so they all have the same, each person has the same, their genetics is not going to change from baseline to year 4, if that makes sense. And then if you go back and we look at our descriptive statistics and our mean body mass index, even just looking at that, and we could chart that, we could chart that, and we would be able to probably see that there is a difference in year 3 compared to the other 3 times. So that is all. I believe I covered everything.